Atomic calculations. What you're going to do in this worksheet is figure out the mass of a compound. And in order to do this, you just add up the masses of however many atoms are in there and the mass of each of those elements. Let me show you what I mean. In this case, it has already given you, for all these problems, it has given you the atomic masses for each element. So you don't have to, on this worksheet, you don't have to go back to your periodic table to find the masses, but later on when you do, remember the atomic mass is the one below the symbol. So for example, boron, I'd be adding 10.81, carbon 12.011, and so on. So here it says find the molecular mass of a mole of sulfuric acid, which is H2SO4, given atomic masses of 1.008 for hydrogen, 32.066 for sulfur, and 15.999 for oxygen. Now, this one has the example worked for you so you can see how it's done. Hydrogen is the first atom in the compound for sulfuric acid. So I have H2. H, hydrogen, has a mass of 1.008, so I wrote that down, and there are two of them, so we're going to multiply that mass times 2. Then we need to add in the mass for S. There's only one of them because there's no subscript here and there's no parentheses, so 1S is 32.066 times 1, again because there's only one of them, and then we want to add the mass of oxygen. 15.999 is the mass of oxygen, and there are 4 of them, so I do that times 4. When I do the parts that are here in parentheses, 1.008 times 2 will give me 2.016, 32.066 times 1 stays itself, and 15.999 times 4 gives me the 63.996, and then I can just add them all together and know that my molecular mass of 1 mole of H2SO4 is 98.078 grams. The whole idea, pardon me, of the mass of a mole, that's the whole reason why we have been using Avogadro's number and 1 mole of something, that's 6.02 times 10 to the 23rd molecules, is that when we look at our periodic table here, I was looking at carbon just a moment ago, 12.011. This is the mass of 1 atom of carbon in atomic mass units, which is about the mass of 1 proton. But I can't measure the mass of an atom in a lab. I can measure grams of things though using a triple beam balance. And if I have 1 mole of a substance, then I have its mass from the periodic table, but now I have it in grams. So if I had 1 mole of carbon, I'd have 12.011 grams of carbon. If I had a mole of nitrogen, I'd have 14.007 grams of nitrogen. So when we ask about molar mass or molecular mass, we're just asking for its mass in grams if we had 1 full mole of it, which would be 6.02 times 10 to the 23rd molecules of the substance. For the rest of these problems, you'll do the same thing. Some of them ask you for the molecular mass, and you're going to do just like we did in the example here. Some of them are going to ask, how many oxygen atoms are in each of these, so you just tell me how many oxygens there are. Molecular mass again. Now, these seem to get people confused, and they're probably the easiest ones on the page. It says, what is the mass in AMU of the hydrogen contained in 1 molecule of HCl? So it's just asking you for the mass of the hydrogen in this. So again, you're going to use your periodic table and find the mass of the hydrogen in this. Here it's asking you for the mass of the chlorine in this molecule. It's a very simple question. Don't make it harder than it is. Here it's asking for the molecular mass of this great big compound. Make sure you add them all up. And the last one is just asking how many atoms there are total. This is just like you did in the counting atoms worksheet where you told the total number of atoms in the entire compound. If you do still have any questions about this worksheet, please come ask me.